So suppose you are asked to derive the following somewhat complex formula. Phi implies, sigma and phi and psi. So that's all between parentheses, and then phi implies psi and psi implies phi, all between parentheses. So this is a relatively complex looking formula, and the first thing you should do is to think about the shape of the formula, and you'll immediately see that there is a main connective, so the implication right here, and that you have all this part here, this is your antecedent, and then all this other part here, which is the consequent. And once you've realized that, then you should ask yourself, what kind of rule is able to give me this formula? What kind of rule is able to give me this formula as a result? And if you go through the derivation rule, so what you should ask yourself is there a rule that at the bottom has something like this? A implies B. And so that would be our A, and this would be our B. So A and B are generic, they stand for anything. So is there a rule that has this kind of shape at the bottom, the shape of an implication? Yes, there is such a rule. It's called implication introduction. Implication introduction. And it has the following structure. So the rule says that if you assume a formula A, so that could be any formula, and you do some derivation steps and you get to B, then what you can do is you can turn this vertical relationship to a horizontal relationship, and you can cancel A because effectively A goes incorporated as an antecedent in your assumption. So whenever you have a formula that has a shape of an implication of A implies B, it's very likely that you're getting to that formula using the rule of implication introduction. So that's something to keep in mind. The second thing to keep in mind is that it's always a good thing to work backwards. What does it mean to work backwards? It means that you should always think, when you have a formula to derive, what rule has that formula at the bottom? What rule has the formula as a result of the application of the rule? So if your formula is an implication, just like this one, so as the shape of A implies B, the rule you should think about is the rule of implication introduction. That is the rule you're going to have at the bottom. So that's the rule that you will need to apply. If your formula has this shape, A and B, let's say, so it's a conjunction, well, the rule that allows you to get a formula like that, if you think of it, is implication introduction, right? And so now if you have a conjunction, what you need to do, working backwards, is just split the conjunction into two and then think about A and B separately. So these are the two general principles that should guide your construction of derivation. So now let's see these two principles in practice. Okay, so this is the rule we want to derive. So since we want to work backwards, I'm going to write this rule at the bottom of our derivation. I don't know what my derivation will look like, but I'm just going to write this at the bottom. I'm just going to write the formula I want to derive at the bottom. And so here we go. So this is the bottom of my derivation, and I write phi implies sigma, and then I write phi and psi implies phi implies psi, and psi implies phi. So this is the whole formula I want to derive. So I just wrote it at the bottom. And because of what we said earlier, regarding the rule of implication introduction, the only way I can get that formula is by applying the rule of implication introduction. So I'm going to write implication introduction here, because that's how I'm going to get that formula. And in the line immediately above this, just following the general structure of the rule of implication introduction, what I should write is the consequent of this. So here I should write phi and psi and psi and phi. So that's my B. So if I go back to the structure of the rule of implication introduction, that's my B, my consequent. My A, my antecedent, should be an assumption according to this rule. So this is my A, and so I should write this as an assumption up here somewhere. You know, I don't know what's going to happen here. I don't know how I'm going to get to this, but I know that I would need to start from that assumption in some way. So I'm going to write it up here. So phi implies sigma and phi and psi. So this is my assumption. Now let's look at what we have here. We have phi and psi, and phi implies psi and phi implies psi. So it kind of goes both directions. This is a conjunction. What is the rule that allows me to get to something that is like a conjunction? So I'm, again, thinking working backwards. Well, the rule is the conjunction introduction that we have up here, that I just mentioned. So it's very likely that I can get to this conjunction by an application of conjunction introduction. So if I work backwards, I should split this into two separate parts. So on the one hand, I have phi and psi. So this is what's on the left-hand side of my conjunction. And then what's on the right-hand side of my conjunction is this. So I have two separate things. So let's think now about each of these separately. So let's start with phi implies psi on the left-hand side. This is an implication, right? So since it's an implication, it's a much simpler implication than the one we started out with, but it's still an implication. It still has the general shape of A implies B. So I will need to use the rule of implication introduction to get that implication. And so I can, again, do the same thing I did earlier with just a much simpler formula. And so write psi, which is my consequent above here, and then my psi here can be an assumption. So I'm going to write the assumption up here. I'm going to write it kind of somewhere up here. And I get this through the rule of implication introduction. Now the question is, I have my psi. What rule allows me to get to psi? Well, there isn't any immediate rule that can tell me that I can get to psi. So I'm kind of stuck at this point. I cannot work backwards anymore. But I have something interesting to work with. So if I go back to this assumption that I have put up here, I can see that I have the phi right here. So I need to have, I have the psi right here. I need to find a strategy to get it out of the formula. And here is the strategy. I apply the rule of conjunction elimination one time, and I take out that conjunction here, phi and psi. And then I apply it another time, conjunction elimination another time, and I take out that conjunct. And so I'm done. Now remember, the rule of conjunction elimination has the following structure. If I have A and B, I can take out A, let's say. Or, again, if I have A and B, I can take out B. That's conjunction elimination. I can take out whichever of the two conjuncts I get. And so A and B, again, are generic. They can stand for any formula of any complexity. And so here, I've first applied conjunction elimination to this big formula here, and I took out phi and psi. Then I applied it again to this simpler formula, and I got psi, which is what I wanted, right? Which is what I wanted. Okay, now let's think about our phi here, which was an assumption. What happened? we assumed phi, so suppose that we assumed phi, then we went through all these steps and somehow we got psi. So we assume phi, we got psi, now we can use the implication introduction to derive psi implies psi. So our assumption here has become the antecedent of our implication. So if I call this assumption number 1, I can keep track of this in this application of the rule, and I can cancel it because the assumption became the antecedent of our implication. And so the assumption is here the antecedent of our implication. Okay, so this branch of the derivation is done. How about this other one on the right-hand side? We're going to follow a very, very similar method. So again, thinking backwards, working backwards, this is an implication. So I'm going to use some version of implication introduction. I'm going to write the consequent immediately above. And I'm going to assume the antecedent somewhere here. And let's call this assumption number 2. Okay, so now here I have phi, and I have psi, and I have phi. How do I get from one to the other? I seem to be stuck. But there is something I can do. I can assume something, and the rule is that you can assume whatever you want. Actually, this is a principle that I should put up here. Assume whatever you want. There is no limitation to that. But you should, of course, assume in an intelligent way because you need to get the things you want. So an assumption that we have here, phi and implies sigma and phi and psi, how about we assume that? And I'm going to assume it a second time. Again, you can assume whatever you want, provided you keep track of what you have assumed. So I'm just trying it out. So I'm assuming this, and notice that I have this phi here inside the formula here, so I should be able to get it out. How do I do that? Well, I do it like I did before. I do 2 applications of the rule of conjunction elimination. So first I take out this, and then I take out the phi, and so I'm good. Now the trick here was that I had to assume this. Why did I assume this? Well, I had it already here. I knew that I would need that assumption because of what I have here at the bottom in terms of an implication, because this is the antecedent of my implication. So I know that this was a good assumption to make. It's still, however, an uncancelled assumption. And so is our assumption here number 2. This one we can call it assumption number 3. Can I cancel this assumption? Because I need to cancel them. I cannot just assume whatever I want and then not cancel it. And so it is true that you can assume whatever you want, but you should cancel the assumption. So you can assume them, but you should be able to cancel them at some point. Okay, so let's see if we can cancel this assumption number 2. We can indeed cancel it, and the only rule that allows us to cancel an assumption is the rule of conjunction implication. Now look at what we have done. We've started with phi, and then we got down to psi, and then we've written here that the implication phi implies psi with the implication introduction. So we incorporated that assumption as an antecedent of our implication. This allows us to cancel that assumption. And so I'm going to write the number 2 here just to keep track of that. So the only uncancelled assumption we have still is number 3. Can we cancel it? Yes, of course we can. Now if you look what we have done here, we've got to this point where we derived phi implies psi and phi implies and psi implies phi. And then with implication introduction, we took our assumption number 3 and we put it as our antecedent here of this very large implication, which is what we wanted to derive. So we have incorporated this assumption number 3 as the antecedent of our implication through the rule of implication introduction. So if I write number 3 here, I can cancel that other assumption. So now we have no uncancelled assumption in the derivation. We have assumed them, and you can assume whatever you want, but you need to be able to cancel them at some point. We've done that. We've followed all the steps that we needed, and so our derivation is essentially complete. We have the formula that we needed to derive at the bottom. There are no hanging assumptions, there are no uncancelled assumptions, so we're really done. We can maybe double check, so let's double check. So we have assumed this, you can assume whatever you want, so that's fine. Now from this we got out phi and psi with the conjunction elimination. We do conjunction elimination again, we got psi. At this point, with the implication introduction, we cancelled our original assumption here, so we got psi implies psi, so we put our assumption as an antecedent of our implication, that's fine. We've done something very similar on this side, and we got phi implies psi, and we managed to cancel our assumption number 2 because this became the antecedent of our implication. Then we put these two parts, this one here and this one here, together with the implication introduction. We can do that. And then the final step, we had the big assumption number 3 here. We moved it as the antecedent of our implication. So we applied implication introduction to assumption number 3. We can cancel it, and we got the formula we needed to derive. And so we are done.